Hello, my name is Vanessa,
I'm Covey.
And I'm Fiona.
and welcome
To
to
the Couch Potato Lab.
where we bring science to your own home. Today we're going to have a very fun and messy activity. But first, let's meet our scientists. On my left, I have.
Hello, my name is Covey. My preferred pronouns are he and him. And fun fact is that in my other life, I was actually an opera singer. Was I good? I don't know. Maybe. But we'll see later on.
I think we'll find out today. You might
Yes,
have to
hopefully.
put those singing skills to use. My name is Vanessa. My pronouns are she and her. And a fun fact about me is that I used to do gymnastics when I was younger, but I was too scared to do a backflip, so I could not continue. On my right, I have.
Hi, I'm Fiona. My preferred pronouns are she, her. And a fun fact about me is I cannot stand eggs.
What? Are you kidding me? How about scrambled eggs?
Nope, don't like them.
What? Hard-boiled eggs.
Disgusting.
Soft-boiled eggs.
Nope,
Devil's eggs.
will not eat them.
Eggnog.
I drink vegan eggnog.
Ah, gotcha there.
So that means no eggs.
No
And-
eggs.
Okay, well that's weird. All right, so we would like to start by recognizing that we are on Treaty 4 territory, which is the traditional territory of the Nehewak, Dakota, Nakota, Lakota peoples, and the Nakaway peoples as well, and the traditional homeland of the Métis Michif Nation. We are so grateful to be able to share this land with these peoples, and to recognize that our audience may be coming from different numbered territories or unceded land. So thank you for taking the time to recognize this and joining us today on Couch Potato Lab. All right, Vanessa, on your desk there is some nice sweet treat, and I
Mhm.
want to eat some. What do you have there?
I have some apple pie, and you're actually in luck because I made this just for the two of you. So
Oh my God.
I'm going to give this pie right here over to Covey.
Nice.
There
Merci.
you are.
Ooh, yummy in my tummy.
And this pie right here over to Fiona.
Oh boy.
There you go.
Ooh.
Oh, I'm so excited. But, Vanessa, how
Yeah.
come I only got 3 pieces of pie?
Oh, look, I have 4 pieces.
How come Covey got more pie than me?
Well, actually, I ended up cutting the pie, like the whole pie, in half. I gave one half to Covey and one half to you, Fiona. Your piece I cut into 3 pieces. So your half of the pie is in 3 pieces. Covey's half of the pie was in 4 pieces. So it's actually the same amount of pie. But I don't know. I don't know that much about that. Do you know more, Covey?
Yes. All right, Fiona, let me educate you about fractions today. All right, so today, so Vanessa gave us 2 halves of a pie. So here's one half, and here's another half. And they kind of like look the same, right? It's the same amount of pie, correct?
Yes.
So we have the same amount of pie, but there's different number slices, right? I have 4 slices, so sucks, and you only have 3. but it's okay because it's still the same amount. So like whatever changes I do to my half of the pie, it's still going to be the same amount of how many slices Fiona has. For example, Vanessa cut my half into 4 slices. But bam, look
just
at
how I did it.
that.
Nice.
Yes. So in total, I would say there's 4 over 4. There's 4 pieces in total, and I still have all those 4 pieces. Then Fiona, on the other hand, how many slices do you have?
I only have 3.
You only have 3. Very good. And 3, and you still have those 3 pieces. But what is 3 over 3, Fiona? Any guesses?
Doesn't that equal 1?
Yes, correct. Because the line right here also means divide. So 3 divided by 3 equals 1, and 4 divided by 4 equals 1. So that means that this half equals the other half. So if I change this to 3 slices, to thirds. Oh, my art skills.
You got it.
But bam, look at that. It's still the same amount. All right, but does that make a little bit more sense, Vanessa?
I think that definitely makes a bit more sense to me. I'm still wondering a little bit about what you've got going on there.
Oh, okay. So you're talking about these boxes, right?
Yes.
Okay, so in fractions, there's a top number and a bottom number. So the top number is called a numerator, and the bottom number is called the denominator. And I'm like, oh, those are like really big words. And I'm like, I don't know if can I remember all of it. Fiona, do you have something that can help me out with this to like remember these big words? And does the numerator maybe go on the bottom or the top or something like that?
Well, you know, I had a great hint that helped me a lot when I was in school to remember which one goes where. So for me, I remembered that the denominator goes down because they both start with the letter D. And then the numerator, well, that's just the other one, so it must go on top.
Perfect. All right, the denominator goes down, so it's the bottom one. And what the denominator represents is the total amount of pieces or slices or parts of something. And the numerator, on the other hand, is the amount that we're using. So for example, if I have these 4 slices of pie, right? The total number of slices of pie I have is 4. So I'm going to put that in the denominator. All right, but what if I quickly ate a pie so fast, like wha-bam, oh my gosh, I ate a pie and there's only 3 slices left. So if there's only 3 slices left, that means 3 out of the 4 slices of pie still exist, and the 1 out of 4 of the pie slices are gone. Dun dun dun. But I know sometimes that like the numerator can like be like greater than the denominator, and I'm like, huh,
So
that's a
Kobe,
little scary.
you're saying that sometimes the denominator can be one number, and then the numerator could be even bigger than that?
Yeah, and I'm just like so confused.
Huh.
Huh.
I'm a little bit confused about that too, because I'm not sure, I haven't heard much of that. Is there a specific word for it? Fiona, do you know?
Well, the fancy word for when the numerator, that's the top number, is bigger than the denominator, the down number, that is called an improper fraction.
Dun dun dun. That's a big word. What does that
Yeah.
mean?
So improper fraction just means that the top number is bigger than the bottom number. There's also another fancy word called a mixed fraction, and that is when you have a whole number with a fraction beside it. So if I go downstairs really quick here,
Bye, Fiona.
oh wow, I actually have another pie.
What?
I know, I really love pie.
Are you going to share it with us?
No.
Okay.
So in terms of fractions, I have 1.5 pies, right?
Yeah.
Yes.
All
Nice.
right. So in a mixed fraction, it would be 1, and then it would be 1/2 beside it. Does that make sense?
That makes a lot more sense. Thank you, Fiona. I think I understand much, much better now. I think I need a little bit extra help, though. I would love to get into the messy part of the activity. What do you two think?
Yeah, I'm ready for that.
I'm
for sure.
excited.
Perfect. So, the messy part of our activity is that we're actually going to be making some slime today.
My favorite.
I'm very excited. So, slime has lots of different components, but we need to know about our materials first. I'm just going to walk over to the handy dandy whiteboard. Turn it around. Here we have it.
Ooh.
Look at that. Very nice. Okay. Let's get our recipe. So, we had Fiona telling us all about our different fractions that we can have. Kobe started us off nice and simple though, so let's do the same. First, we have half a cup of glue. Liquid glue, clear or white, doesn't matter. So, let's make a half. I'm going to put the whole number on the bottom, so let's just use 2, make it pretty easy. And then half of 2 is just 1. There we go. Half a cup of liquid glue. Next, we're going to have 1.5 cups of foaming shaving cream, which looks just like this. And we're going to use a mixed fraction for this one. So just like Fiona told us all about, we're going to have our first number, which is just 1. And then the rest of it, it's not a whole number, so we're going to have a fraction again beside our whole number. And this time it's a half again. Once again, we'll just have our 2 and then our 1 on top. Easy enough. And then now, these were in cups, by the way. We're going on to tablespoons, so it's a little bit smaller. But we'll have 2.5 tablespoons of contact solution. I don't know, why do we use contact solution, though? That seems kind of interesting.
Oh, I think I have an idea of what that, why. So contact solution has a chemical called boric acid or sodium borate, which is very, very important for making slime. So if you're using contact solution, make sure you look at the ingredients and find that either sodium borate or boric acid, or you can find it also in liquid detergent. So check out the ingredient list and see if you can find either one of those 2 ingredients, and your slime will be able to work. Does that help, Vanessa?
That helps a lot.
Perfect.
Thank you so much. I feel like we use the glue too. It probably just makes it sticky. The foaming shaving cream makes it very fluffy and easy to work with. But let's find out our measurement for our tablespoons of contact solution. So once again, it will be a mixed fraction. We're going to have 2 this time. And then our fraction with this one is going to be a half once again. We're experts at this part now. So we have 2.5 tablespoons of contact solution or liquid laundry detergent, of course. Finally, our 3 drops of food coloring. This part is optional, but it makes it extra fun. So you can have some colored food coloring. Your colored slime. So yeah, that's our recipe. Is that enough amount for you, Covey?
Okay, to be honest, I don't like those measurements because I want to make more slime. I'm like really into slime, and I have a brother at home, so I want to make a little bit extra for him as well. So what I'm going to do, I'm going to double the amount of each ingredient, so the fractions are a little bit different. So instead of half cup of liquid glue, I'm going to use 1 cup of glue instead. And then instead of using 1.5 cups of shaving cream, I'm going to use 3 cups of shaving cream. So I'm doubling each fraction by multiplying it by 2, so that we get the right amount. Next one is instead of 2.5 tablespoons of contact solution, I'm going to use 5 tablespoons. So I pretty much times 2.5 by 2. And the last one, maybe 6 drops of food coloring. Maybe I might stick with 3. Maybe I'll double it. I don't know for sure. I think I'll play it by ear. Yeah, so I'm gonna make double the amount, so I have lots of slime to share with my brother and maybe my friends if I would like to. All right. Yeah, so that's what I'm doing, Vanessa.
That's very nice, Covey. You'll have lots of friends probably asking for slime because it's going to be awesome. I think for the food coloring, if you wanted really light colored slime, you could use just a little bit of food coloring. If you wanted it to be really dark, then you could use lots of food coloring. I'm probably going to stick with 3 drops, keep it in the middle. What about you, Fiona? What are you thinking on amount of slime?
Well, I'm not a big fan of slime because slime is slimy. I don't like slime.
What?
I know, I don't like eggs and I don't like slime.
Wow.
So I'm going to cut mine in half. So what I've done is I'm starting out with 1/2 cup of the liquid glue, and I'm going to turn it into a 1/4 cup. Now the way I'm going to do that is if I use just 1/2 to make it into a 1/4, because I'm halving it, I'm going to cut it in half again. So I'm only going to use this much.
That's a little.
And I know, I don't like slime.
Just don't. You're barely going to have any slime, Fiona.
That's okay.
That's okay. Good. Good.
So next we have our shaving cream. Now this one's a little tricky because we start with 1.5 cups of shaving cream. And half of that is actually equal to 3/4. Now to show you how that works, we start with 1 whole cup, and then we're only going to use half of one of these. And we need to turn each one of those into half. So first I'm going to cut this half. So this is 1/2 that we're going to be using. And then this is the 1/2 cup that we're now going to cut in half, and that equals 1/4. So what we're left with is 1/2 cup that we cut in half, and then we have 1/4, and 1/2 cup plus 1/4 cup is equal to 3/4.
Nice.
I know, it's some big math right there. And then finally we have our contact solution, which we originally used 2.5 tablespoons of, and we're going to turn it into 1 1/4 tablespoons. So we're going to cut each of these in half those are our whole numbers, which were our 2. And then we're going to cut this half in half. So then we have these ones left. So we have half a circle plus a half a circle equals a whole circle plus a quarter of a circle's colored in.
Ooh, I love the
Nice.
visuals, Fiona. That's real good.
Thank you. I tried really hard.
I feel like I could even cut a recipe in half now. We have a quick question now. This is from Cole, I believe. Yes, so it's from Cole. Cole is wondering, how are fractions, percents, and decimals related? So I know that they're all very similar, but I'm not totally sure on the specifics. Does anybody know?
So like fractions, percents, and decimals, it's really easy to talk about it with money, which really helps. We're going to talk about that later on in the episode, but pretty much if, for example, if a fraction is 1, right, 1 pi, that's just 1. If I cut it in half, then it would be 1 over 2. 1 would represent in percentage-wise, it would represent 100%. 100% means the entire thing. And if we cut it in half, right, if we divide by 2, then 100% would become 50%. So that's how it relates, thinking that a fraction, if it equals 1, equals 100%. And we can also represent that as a decimal as well by the number 1. And if we cut it in half, it will be 0.5. So a calculator will be your best friend if you need to calculate percents and decimals as well for that. Yeah,
Thanks,
hopefully
Kobe.
that helps.
Yeah, that helps me a lot. I hope that helps you, Cole. And stay tuned because we're going to get into that a lot more later when we're talking about some money. So yes, I think, if I'm not mistaken, we're ready to build our slime and make it.
Yes.
Perfect. Okay.
I'm ready.
So what are we doing first? I think we need our bowl
Mm-hmm.
and something to mix with. So I have a popsicle stick. A spoon would work.
Maybe
Anything.
your hands.
Yes, hands would work. We have some gloves just in case we want to get a little bit extra messy. So we'll add first our cup of our glue. I have half a cup. Everybody has different measurements right now.
Yeah, so I'm going to do 1 cup of glue. And Fiona, remind me how many cups of glue are you going to use?
I'm using a 1/4 cup of glue, so I don't have very much slimy slime.
Okay, maybe once you start making the slime, you're going to really love slime. We're going to convince you. Maybe it'll look super cool.
We'll see. We'll see, Kobe.
All right.
I hope you end up liking it because it's pretty fun. But yeah, I'm just going to be pouring this very large liquid glue into my half cup measurement. I'm hoping not to spill, but we were ready to get messy, so it's okay.
Yes.
All right.
Perfect.
How'd that pouring go for everyone?
Pretty good.
Okay,
That's a lot of glue.
that is a lot of
All
glue.
right,
You
so
should have
glue
more.
is a very important component of slime because it's made out of lots of polymers, and polymers are pretty much long chains of different molecules that we learned yesterday. So molecules again are two chemical atoms bonded together or stuck together, and polymers are just those molecules but all stuck together and more. So it's a long, big chain. But because it's the glue is pretty flowy, and that's because these polymers are able to slide between each other. Yeah.
Cool.
So that fun
That-
fact. Hey, what's next?
We've
Vanessa?
got our shaving cream right here. Make sure it's foaming, and we're just gonna do our measurements. I have 1 cup and then also half a cup. My biggest measurement is the half a cup, so I'm gonna need to do this 3 times to make it work. How's everyone else's measurements?
Well, I am going to use 3/4 of a cup of shaving cream. So I have a half cup here. So I need to do 1 of these and about half of 1 of these containers as well. And Vanessa, do you know what the shaving cream does in this slime?
I thought it just made it nicer to feel. Kobe, do you know exactly what it does or what its role is?
Yes. So what shaving cream does is makes it fluffy. Yep. It's a fluffy slime. And Fiona knows another reason why shaving cream is important too, right, Fiona?
Yeah, so it makes it fluffy. It makes it a little less sticky too, actually. So it takes away some of the stickiness that the glue has. And the slime it makes it nice and fluffy because I like fluffy slime is a little better than slimy slime, I guess.
You're more okay with it? It makes it stick less to your hands, maybe?
Yeah.
That's pretty good. Yeah, mine's, I don't know, my measurement, because when I put the shaving cream in, it gets a lot bigger. So I've only done a cup, but I might leave it like that for now and possibly add more later. If you're feeling like you might have a lot, we can kind of play around with it. Different things will happen as we add our ingredients, and your slime needs to be experimented with a little bit because we're all scientists, so we got to figure out what's going to work best, what's not going to work. But is everybody done and ready with their shaving cream?
Correct. Yes.
I'm done.
Perfect.
Whoop,
Okay. Next on the list, we have contact solution or laundry detergent. Either one works. We're moving into tablespoon territory now, so I'm going to get my tablespoon out. Everybody else ready with your contact solution?
Aye.
Perfect.
All right.
Okay.
And Vanessa, do you know why we're using contact solution and liquid detergent? Why is it
Well,
important?
wasn't that earlier that you were mentioning that it was the activator in our slime? So yes, it helps everything start working together. Do you know more about that, Covey?
Yes, very good. So that is correct. Slime activators like the liquid detergent or liquid starch has a chemical called sodium borate or boric acid, and this is called the slime activator. So what's happening here is this chemical reaction between the glue and the activator and the shaving cream and the food coloring. Those are the reactants, and going through a chemical process, and it's going to change its form. So this slime activator changes the polymers of the glue so that it sticks together a little bit more, making it more of that slimy texture that we all love. So that is why the slime activator is one of the most important ingredients to slime. Make sense?
Yes, that
Yeah.
helps me a lot. We're finally just going to add our food coloring. I'm using blue today. I'm going to have about 3 drops. You can have whatever follows your recipe. 3 drops if you want it darker, more, lighter, less. And then we're going to get to mixing once we put that in. And while we're mixing, we have some questions. So our first question is, are the fractions 5 out of 15 and 1 out of 3 the same thing? I think so. What do you two think?
They sure are the same thing. So it's almost like if you had, to make 15, you need 3 sets of 5. So it would end up being the same thing. In order to make, to make a whole, you need 3 sets of 5. And that is the same thing as 1 over 3 because they both have that 3 number in there.
Okay.
Mhm.
Thank you, Fiona. That helps me a lot. We have one more question. This one's coming from the Hayes brothers. The question is, can fractions have remainders? Do you know the answer, Covey, while we're mixing?
Yes, fractions can. Fractions, the thing is, fractions are remainders. So remember, fractions is kind of like division, right? So that line between those two numbers is kind of like a division sign. So of course you can have remainders for sure. And a fun fact is that the division sign is actually a fraction. Yeah,
No
so it's a
way.
dot and then a line and then another dot at the bottom. So those 2 dots are just like a blank space for numbers. Yeah.
Like our denominator and our
Oh.
numerator?
Yes, Fiona, very good. Yes, yes, you are
Perfect.
correct.
What do those mean again, Fiona?
Oh, let me think.
Or what's the trick?
Down. Down is denominator. The bottom one is your denominator. And that would
Perfect.
leave your numerator to be the top.
Yeah,
That makes sense. That makes a lot of sense.
yeah. So what doesn't divide eventually goes on top. So I think so the like those what's it called, remainders, they are when the fractions don't divide equally. So example, like 4 divided by 2 equals 2, but 5 divided by 2, they don't divide very evenly. So you have like a remainder of like 0.5, something like that.
Okay,
Like 1.
cool.
Yeah.
Yeah, that makes sense. I think sometimes when you can't divide all the way, you just got to do something with the rest. I'm getting a little distracted because I'm so messy, and I pranked myself earlier actually because I definitely needed that extra bit of shaving cream. It just looked like a lot, so I wanted to play it safe, but I'm going to add my other half a cup of shaving cream. Try not to get myself too messy, but it might happen. That's okay. Science is
Ooh,
just that way.
Fiona, yours looks so good.
Yeah, I'm pretty excited about it. I think it looks pretty cool.
Oh my
I think
gosh.
it looks pretty slimy. It seems to be stretching like slime. I think I'm going to add another drop of food coloring though, because it's still pretty white. But you know, that's okay, because sometimes, depending on like what the weather's like, sometimes there's humidity in the air. That's like the wetness in the air. Sometimes that can affect your slime. So if it's still pretty slimy and it's not coming together, maybe you want to add some more contact solution or laundry detergent to create that chemical reaction a little bit better. And if it's sticking together too much, maybe you want to add a little bit more glue and shaving cream.
Yeah, because if like mine right now is like kind of very runny. So I think I need a little bit more slime activator to connect those polymers. I kind of ran out. Fiona, is it possible if you could pass me the bottle of contact solution, please?
Oh yeah, for sure.
Let me get my hand in my glove and I'll help the pass along.
Okay, for sure.
I got extremely messy by accident, but that's okay. I think we have paper towels somewhere. There you go,
Perfect.
Kobe. Is
Thank
that
you.
Here, I'll open it for you. Okay, there you go.
Awesome.
Good
thank
luck.
you. Oh my gosh.
My glove's right in the slime now. I think it might be time for a new one.
We did warn you it was going to be messy.
That's right, but makes it fun. I'm excited to play with my slime. Oh my goodness.
So Fiona, what color did you use for your slime?
I am trying to make purple. So in order to make purple, I mixed red and blue in even amounts. And combining those two, I'm hopefully going to make some purple. Right now it just looks like red and blue though.
Hey, you'll get there.
It's got a mix.
It's got a mix. What about you, Kobe? What color did you pick?
I picked green because this kind of looks like mint ice cream. And I love mint ice cream. That's my favorite ice cream flavor. But I'm not going to eat this because this is not going to taste very well at all.
Don't eat
And
science.
don't eat science.
Right.
Exactly. Okay, so I'm like, it's still runny. So I need a lot more.
Do you need more
Um,
activator?
Yeah, I think I need more activator.
I think I might also need some more activator, but I think I have a little bit left. I'm just going to add everything I have.
You know what, Covey and Vanessa?
What's that, Fiona?
I think I actually like this slime.
Really?
You do?
I think
convinced
I
you.
do.
Good.
Look, it looks very fluffy. I can pull it apart and stretch it. I think you changed my mind.
Good. I'm so glad. Slime is fun. I really like slime, even though it is pretty messy. But my
Ooh, I love that texture.
look at that. That is really something. I don't know how you got yours so perfect, Fiona.
Yeah, what the heck?
I
I'm
was
so
really,
stirring.
I was really eyeballing mine, so I think that might have been part of the issue, but
Yeah,
that's okay.
You know, Vanessa, I do a lot of baking at home,
Oh.
and baking has a lot to do with fractions. So I think I just have lots and lots of experience and lots of practice with using fractions. So that when I do this, I can get it pretty good the first time, I think.
Okay. Yeah,
Alright.
that's good to know.
All right, so I'm content with my slime now.
Uh,
It's so good. Mine's a little bit runny than expected, but I think I'm done with my slime. It's pretty good.
Really?
Yeah.
I'm very jealous of you. I don't know. Sometimes it just gets a little bit too messed up. But at least my scientist friends on the side had theirs turn out, so I'm very happy for them.
Yeah. So
Yes.
so I heard that slime is like there's a big word for what slime is, and we talked about states yesterday about like solid and liquid and all and gas and plasma. But like I know what is slime? Is slime like one of those states? Vanessa, do you know?
I'm not totally sure. Do you know, Fiona?
Well, I have a fun fact for you. There's a really big word, and slime falls into this category. It's called a non-Newtonian fluid.
Oh my gosh, say
That
that
is
5
a big
times
word.
fast.
Non-Newtonian fluid, non-Newtonian fluid, non-Newtonian.
You were pretty good. You were going. I like that.
I use those words a lot in school.
Ah, yes, yes.
So yeah, basically what a non-Newtonian fluid means is that if you apply pressure or a force to it, so if you squeeze it, it will flow differently than if you didn't. So if you see when I pull this up, it just kind of sinks down and it kind of goes in a nice straight line. But if I were to grab some and then squeeze it, it kind of goes all over the place and it flows faster when I squeeze it than when I don't.
So is it more liquid when you squeeze it or more liquid when you just let it flow?
I would say it's more liquid when I squeeze it because it moves faster.
Oh, okay. That makes a lot of sense. Cool.
But, you know, that is not always the case with non-Newtonian fluids. Sometimes when you push on them, they act like a solid instead of a liquid.
Cool. Do you have an example of that?
There's a really cool example that we're gonna do today, and it's called Oobleck. This is something that you can do at home too because it only has 2 ingredients. It's cornstarch and water.
Cool. That's really awesome. Do you have an example too of maybe a fluid that is Newtonian and reacts normally?
Yeah, so there's a lot of fluids also that are called Newtonian fluids. And those are fluids that just kind of act normal when you just leave them be in everyday life. So some examples of some Newtonian fluids is water, because if you push on water, it's going to act the same. Air, because, you know, if you try to wave your hands in the air, it doesn't feel like you're hitting a wall or anything. Let's see, what's another one? Milk is also a Newtonian fluid.
Question for you, Fiona.
Yes, Kobe.
Is an egg a non-Newtonian fluid or a Newtonian fluid?
Let's see here. I would say, I don't really know the answer to that one. I would possibly say that it's a Newtonian fluid though. Or maybe even if you were to burst the egg yolk would be a Newtonian fluid, but possibly the egg white would be a non-Newtonian fluid, because you know how you feel the egg whites and they kind of stick together and you really got to mix them in order to get them to flow nicely. So I think maybe that would be my verdict. We can maybe look it up later though and get a real definitive answer.
That makes sense. Good question, Kobe. Now that we know about Newtonian fluids, non-Newtonian fluids, I'd love to test out this Oobleck. Does anybody know how to make it?
Yes, I know the secret recipe to Oobleck, and Oobleck is our boss's favorite thing in the world. So Oobleck, like what Fiona mentioned already, is only 2 ingredients. So if you want to follow along, you can as well, or you can do it later on. So what you're going to need is water and cornstarch. So those are the 2 things that you need. And the recipe calls for 2 parts cornstarch and 1 part water. So instead of a fraction, it's actually a ratio. Yeah.
What's the difference between a fraction and a ratio? I'm not too sure on that.
Oh, okay. Yes. All right. So in our prior episode in reaction-based ratios, we learned a lot about that, so you can check that out. But I'll give you a little recap. So a ratio is like a comparison between 2 different things or more. So right now we are comparing cornstarch and water. So there's going to be 2 dots, a colon, and 1. So 2 to 1. The cornstarch ratio is a cornstarch to water ratio is 2 to 1. Fractions, on the other hand, is a number that represents pieces and parts of a whole. So instead of that, it wouldn't be 2 over 1. It'll be a little bit different. So in order to kind of like use that in our recipe, let's just use a spoon, any spoon. So I'm going to use 1/3 of a cup. But what it means is that 2 parts against 1 part of cornstarch to water is kind of like 2 scoops of cornstarch and 1 scoop of water. Yeah, that's pretty much it.
Well, that sounds pretty easy. While Kobe gets that started with his cornstarch, we have one quick question. This is from Alex. Would you rather have a this would be 4/5 of a cookie or 1/3 of a cookie.
Ooh.
Covey, what would you rather have?
I would rather have 1/3 of a cookie.
Okay.
Yes.
Fiona, what would you rather have?
Covey, do you
What?
not like cookies?
What do you mean? I love cookies. It's like my favorite.
But 4/5 of a cookie is bigger than 1/3 of a cookie.
What?
I would have 4/5 of a cookie.
What? How does that work?
Well, it's because 4/5 is, oh, let's see. If you cut a pie if you cut a pie into 5 pieces, you'd be eating 4 out of those 5 pieces, which is a pretty big amount of pie. But if you were to cut a cookie into 3 pieces, you'd only be getting 1 out of 3 of them, which is less than half.
And these 3 pieces, those pieces have to be equal, right? So like the 5
Yes.
pieces have to be equal.
Yes, they do.
Oh, right. 4 out of 5. That means 4 pieces. 4 pretty big pieces, and then a third would be just like less than half. So, 4 5/5. You're
Okay,
right.
That
I
makes
changed my
sense.
answer.
I will also go with 4/5 of a cookie because I would like to have the most of it. So, while they're building their Oobleck, would anyone borrow me or I guess lend me their cornstarch?
Yes, I am
Perfect.
done. Here you are.
Okay.
Oh, thank you. Okay, you said your Oobleck was done?
Correct.
Could you give us a tour?
Yes. All right. Taking a look at my Oobleck. So, just a reminder of non-Newtonian fluids. It's kind of like a liquid, kind of like a solid, right? So, for example, this is good stuff. Some good stuff. All right. I'm gonna take another bowl. All right. If I pour this Oobleck, it's kind of liquidy, right? But when I crush it up, it's like a solid again. Yeah. That's some good stuff.
Cool. It really changes. How's yours, Fiona?
I think I might have put too much cornstarch in mine.
Could you add more water then? Do you think that would fix it?
I think it would fix it. Maybe my ratios were just a little off. I may have measured it wrong. I do know that I think I added a little too much cornstarch because I thought it wasn't enough. But now it's too much.
It's okay. We can always fix it. The interesting thing about Oobleck too is I'm actually having a hard time mixing because as the cornstarch and water forms, when I apply my force to it with my spoon just to mix it, it makes it hard because the Oobleck itself becomes solid and won't let me move it around. So Oobleck is pretty cool with that. And mine isn't really working, unfortunately. It's really, really liquidy, but yeah, it's not doing too great.
Ooh, Fiona, I have a question for you.
Yes.
So we experienced 2 different non-Newtonian fluids now. So we got slime and Oobleck. Which one is your favorite?
Well, personally, my favorite one is definitely Oobleck. I've been playing with Oobleck a long time, ever since I was a kid. And it's just, I find it's a little less messy because when it gets on your hands, it just kind of dries up and you're left with cornstarch again.
True.
But yeah, I think definitely Oobleck. I also like how different it is because it goes definitely from a liquid to a solid and it's very noticeable, the difference. So I think that's really cool too.
That is really cool. We have a really, really great question right now from Katrina. Is it true that you can walk on Oobleck? Fiona, it's your favorite. Do you know?
I do. It is true. You can walk on Oobleck. It works a little better if you kind of stomp when you go across, and so that you create lots of force and lots of pressure on it, because then it turns into a solid when there's force applied. But yes, the answer to that is you can run across Oobleck.
Huh. That is really cool. Well, it seems like I'm a big fan of non-Newtonian fluids now, but both of mine turned out really, really poorly. So we're going to have to make a deal. Something like that. But looks like we have a question coming in. That was the eggs. Okay. So this is our egg answer. According to fluid dynamics of liquid egg products. Okay. The flow behavior of a fluid can be varied from Newtonian to time-dependent non-Newtonian in nature, depending on its origin. composition and structure, behavior, and previous history. So in simple terms, it seems like maybe depending on the time it's been around, where the egg came from, so what animal laid that egg, that kind of thing, it really depends. So kind of a gray area with Newtonian fluids there. Now that I am a big fan of the non-Newtonian fluids, I was wondering if I could make a deal with you two.
Ooh.
What's that?
Fiona, your slime turned out so well. Could I buy some from you?
You know, I don't like slime very much, so you can have it.
Okay, sounds good. I'm going to put this loony into my cup, and I have a nice grabber right here. So we're gonna transfer this safely to Fiona, I hope. Okay, are your hands clean? Enough?
They got cornstarch, but that's okay.
There you go. Okay.
Oh, wow.
Covey,
Yes.
your Oobleck was great.
Yeah, I know it is.
Would you be willing to give it up for me?
Sure, why not?
Okay, sounds great. I'm going to give you 4 quarters. Okay, here it comes. I'm putting it in
Nice.
my cup. Gonna use my grabber. Pick it up again. Ooh. Okay, I gotta get a good grip on this. I don't want it to fall. All right, here it comes. One-handed. All right, I'm gonna do my best.
Nice.
There we go.
Wow, I got 4 coins and you got 1.
Wait a minute. How come I only got 1 coin? How come Covey got 4?
Well, this is a really great example. This is the decimal stuff we were talking about earlier. So when it comes to money, we have lots of, like if we're talking about $1, we have 100 cents. So it would be hard to represent all of that using fractions. So we get into our handy dandy decimals. So decimals are a little bit easier to work with, especially talking about money and when we get into smaller things. Like, for example, if you were buying something and the price was $6.99, it would hard to be representing that as a mixed fraction. And remember, a mixed fraction is when you have a whole number and then a fraction right beside it. It would be hard to represent it like that because your numbers would get so big and crazy. So we can just use a nice decimal. That's why when we are looking at our money, we get to say it costs 6 period, like at the end of a sentence, which is the decimal. So 6.99. And that is our decimal. It's really great to represent any number between 2 numbers. So if we were talking about any number between 6 and 7, we could talk about it that way. Yeah, that's pretty much why you, Fiona, got $1, which is only 1 coin, but it's 100 cents.
Mm-hmm.
Covey, you got 4 coins, 4 quarters,
Yeah.
and they are 25 cents each. 25 times 4 is
100.
oh, perfect. So that
Yeah.
is still $1. Both of you got $1. It was the same.
Oh, makes sense.
Oh, okay.
Mm-hmm.
Well, then it's okay. I'm not upset anymore.
I'm so glad. Okay, so I think we have a question. Okay, this is from the Hayes brothers again. Can you use flour instead of cornstarch to make oobleck? I'm not too sure. Does anybody know?
Give it a shot, I would say.
Okay,
Not too sure. I think so.
okay.
I'm not too sure about it. I do know you can use arrowroot powder instead of cornstarch. That's another substitute you can use, but I'm not too sure about flour. I don't
yeah, I
think
don't
it
think so,
will. I
no.
think it'll, 'cause like it's like if you're making bread, you put water and flour together, and it just kind of makes a dough. It doesn't quite make the same texture as oobleck would.
It seems like it would make more of a paste instead. So you can even make some simple homemade glue like that. It seems like it might just be water and flour. So that's pretty cool. We have another question. This is from Cameron. He wants to know what happens when you add a third and a quarter.
Ooh, I can tackle this
Oh.
question.
Let's see, Covey.
All right, so we're gonna have to use a little bit of multiplication on how to add these fractions together, because the 2 denominators are different, right? So what we have to do is to find a common denominator between 3 and 4. So one thing that really helps me is that if these 2 common denominators are a little bit on the lower side, so 3 and 4 are pretty low, I like to multiply them by of each other. So for example, I'm going to multiply 3 by 4, and I'm going to whatever happens to the denominator, you also have to multiply the numerator as well. So if I multiply the denominator by 4, you have to multiply the numerator by 4 as well. And for this one, 1 out of 4, I would have to multiply it by 3. Same thing, if I multiply the denominator, the numerator is multiplied by the same thing as well. And if you take a look, if I put a fraction line right there, 4 over 4 equals 1, and 3 over 3 equals 1. So you're pretty much not doing much to it. We're just changing the form of it. So Fiona, what is 3 times 4?
It is 12.
12, very good. And then what's 1 times 4?
Well, that one's easy, Kobe. It's 4.
Yeah, nicely done. All right, and Vanessa, what is 3 times 1?
3 times 1, I think it might be 3.
Nice. And 4 times 3?
12 again. That's
Good,
the same thing
perfect.
as the other denominator, just the other way.
Yes, so the denominator now is the same thing, so we have the common denominator, and because of that, we can add them together. So what's 4 plus 3? Fiona.
7.
7, very good. So the answer is 7 over 12.
That was super good math, Kobe. Thank you so much, Cameron.
No
I hope that
probs.
helps you out. Well, let's have one more quick question, and then we have our fantastic potato problem coming up. So the question is from Sierra. Sierra's asking, so the gas gauge in my mom's car is actually measuring the fraction of the gas in the gas tank. Is that right? Fiona, do you know?
Yeah, it sure is actually. So a gas tank on the car is usually split up into 4 main parts and 8 smaller parts. And yeah, it's a fraction. So if your little arrow will show it at the halfway mark if your tank is half full. So that really is a great example to show that fractions really are all around us, all over the world.
Wow,
Perfect.
that's really awesome. Thank you, Fiona. And Sierra, I hope that helps you out. So I think we're ready for our potato problem now. We have the most spectacular choreography and a little bit of a song for you all. So we've been practicing this very hard to introduce the potato problem. Okay, Kobe, Fiona, are you ready?
Yes.
I'm ready.
Okay, it's time for the potato problem.
Problem.
Wow, good job,
Nailed it.
Kobe. That was excellent. I feel extremely ready for the potato problem now. Fiona, I'm going to start off with you for your
Alright.
first mission. The whole idea of this is that we are going to have our scientists, and you at home, you're also our scientists, you're going to be designing a secret agent tool. So we need to engineer a secret agent tool using our slime. So it's going to be a little bit of a challenge. Fiona,
Okay.
your specific mission. You're going to be coming down from a string on the ceiling, okay? There's something that you need to get. It's very important. We know about it from a couple episodes ago. You're going to have to grab the golden ratio gold that was stolen by the pirate. So you're going to need to use your slime in your design for your secret agent tool to figure out how you're going to get that gold.
All right.
Mission 2, off to Kobe.
Hello.
Kobe, of
Yes.
course, you know this is coming. This happens every
Okay.
episode. You're stuck in space.
Again?
Again.
Oh my gosh.
This time, the issue for your potato problem is that you are locked out of your space station, and you need to use your slime to get back in somehow. Use your secret agent tool, engineer it with your slime, get back in your space station.
Okay,
Okay,
alrighty.
go ahead. Scientists at home, this is your mission, mission number 3. You're going to be a stampede of aliens is coming for you. That is the issue. And what you're going to need to do is use your secret agent tool to design something using your slime to stop the aliens from getting to you. Anything you want, anything you can think of, feel free, let us know what you're thinking. We would love to hear it. So let's see. Fiona, I let you start first. What's your thought process, design process? How's it coming along?
All right. Well, the main thing I'm thinking about is I need to make something that can reach it from a distance. And you know, I'm actually already done. I'm a super fast drawer.
Wow.
So I have designed something, and I'm calling it the Sly Yo-Yo.
That's pretty good.
Yeah,
I like it.
So since I'm in the air here, this is me and the ceiling, And this is my yo-yo that's coming down, and it's covered in slime because slime is kind of sticky. And I wanted it to be able to throw it all the way down to the gold here, and I want the gold to stick to the slime on my sly yo-yo. And then, because it's a yo-yo, it's going to come all the way back up to me here at the ceiling. So that is my super spy gadget.
That is super creative. You must be an engineer.
I am in school, actually, for engineering.
Very nice.
Ooh, oh, a couple of episodes ago, we were trying to guess what type of engineer you want to be.
Ooh, yes.
What kind?
I am in school right now for biochemical engineering.
Ooh.
So what that is, I'm going to be doing a lot of chemical engineering, which has a lot to do with Newtonian and non-Newtonian fluids. It has a lot to do with pressure, how liquids flow, and then I added the bio part because I want to do some stuff maybe with the human body.
Wow.
So maybe how like blood runs through the human and stuff like that.
Cool, because we're made out of chemicals technically, right?
We sure are.
Wow, that is so cool. Awesome. Thank you, Fiona. And I love your sly yo-yo. Covey, you had the second mission. Your mission was that you were locked out of your space station. How are you getting back in?
All right. So what I designed or came up with is called the Sligo Ring.
Ooh.
All right. So what's gonna happen is that you're going. I have this little ring attached to my finger, and up top, it's kind of like a ball right here, and inside is the slime. Yes. So pretty much is that when I press one of these keys right here, it's going to launch slime from the bracelet to attach to whatever I aim it at. And what helps with my aim are these little dots around the orb of the ring. So these ones connect, kind of like sense your surroundings and maybe other signals from like the spaceship, right? Because I might be lost. Space is super dark, right? So these rings are like the detectors, and inside is the slime that will be launched when I press the button. And once I get that, I can shoot it across, attach it to my spaceship, and it will like drag me all the way back to the spaceship. I'll knock on the door and be like, yo, my friends, save me. Open the door. I need to get out of here. Yes, so this is my Sligo Ring.
Wow, I love that. You two are both so creative. I love your two designs. I'd love to see all of our scientists at home designs. And now we're ready for our Ask Our Scientist segment.
It is time. Do.
So, our first question for our scientists is, how should I store my slime so it stays good for longer? Fiona, do you know?
I sure do. So a great way to store your slime is in an airtight container. So that could be some sort of container, kind of like this even, and you want to put a lid on it so it doesn't let any air in, because you don't want the air to dry it out or anything.
Sweet, perfect. I think the slime that I bought from you, I might have to put in an airtight container.
I would recommend that.
Awesome, it'll stay perfect for a very long time. So our next question is, what if my oobleck gets too dry? Covey, do you know?
Yes, if it gets a little bit too dry, just add water. That's all you need. Just add a little bit of water, mix it around to see if it's the right consistency. If it's not, then keep adding a little bit water. So I'm gonna say like add water moderately and gradually. It's like slowly and just a little bit at a time, so you make sure that you don't go overboard with your oobleck. Yeah.
Perfect. That makes sense. Okay, our next question is, what is your favorite animal species? I think we could all probably answer that. Fiona, do you want to go first?
All right. My favorite animal species is wolves. I've always really liked wolves. I used to read lots of books about wolves as well, and even werewolf books as well. So ever since then, definitely wolves is my favorite species.
Nice.
Ooh.
That's really awesome. I think my favorite species, I really like cats. I talked about it a long time ago in an episode about my two cats at home. I love them so much. They're such good companions. They'd have to be my favorite. What about you, Covey?
Ooh, okay. So there's a lot of species I like, but one of the species is called Galeria melanola. And actually, they're called waxworms, and I did a little experiment on them during my undergraduate university year, and it's really fun. I played with them, and it's a great time. Yeah, another one is called the tardigrade because they are almost indestructible, which is crazy. So if you want to find more about some species like that, head on over to our Instagram at Eyes Youth because we have a Species Sunday segment every Sunday, and I introduce you to a different species, and hopefully you'll learn a little bit of something. Yeah.
Cool.
So yeah.
I'll definitely check that out on Sunday. Ben, we'd love to hear what your favorite animal species is. That's really great. Thank you for that question. Okay, we've got a little bit of a response on some of our viewers, our scientists at home, on what they built to keep the aliens out. So it looks like Cameron and Joe built a giant slime wall to keep the aliens out, and I think that is perfect. I bet you would have had to multiply the original recipe by a lot, though. Maybe by 100?
You need a lot of slime
you need
for
a lot
that.
of slime for an entire wall. Well, I think... Oh, we got one last question. Is that a tardigrade behind you, Covey?
Yes, this is the tardigrade that I was talking about, this indestructible little tiny microscopic animal, and it's super cool, and yeah, it's super dope. So yeah, take a look at that, research that on the internet.
Perfect. It's kind of cute, I think. That is all we have for you today. We would like to thank our supporters, Actua and the University of Regina. And you at home, thanks for tuning in. See you tomorrow. Bye.
Bye.